In the Capability Maturity Model, or CMM, we can get a measure of how good we are in our organization in regards to our software development. The model measures how good we are at what we do now, but it also gives us some practical steps that we can implement to get us to the next level. And the model uses 5 levels: level 1, 2, 3, 4, and 5. And level 5 is where we want to end up. And as we level up, we get more and more organized, the processes and the outcomes are repeatable, and that is where we want to end up. So level 1, that's an initial. Our processes are undocumented, they're often driven by an ad hoc need for them, they're uncontrolled, and they're in a reactive manner. Meaning, we need something, then we do it. But we don't have a roadmap on how to get there or how to do it. And this is a very chaotic and unstable environment for the processes and to work in. I have seen shops like this. If they manage to finish a product on time and on budget to specifications, it's pretty unusual. Normally, most things break and stuff doesn't happen on time or on budget. So if we get a little better, we get to level 2. That's also called repeatable, meaning that many of the processes we have are repeatable, and possibly they would have a consistent result. Not always, though. Our process discipline is still not very rigorous, but it is there, and it can help us to ensure that we have those existing processes in place and they're being maintained in times of high stress. Level 3, defined. We get a little bit better again. We have a set of defined and documented standard processes. They're in place and they're being improved over time. But we may still not be using them enough, but our staff may not be used to using them yet, or we might not use them for everything, which means our users are not that competent in using the processes, and the processes themselves may not have been validated to function in a lot of situations. But obviously, we improve. Then we'll get to level 4, and that is either called managed or capable. At this level, we use process metrics. We can measure how well we do, and we can see proof that the processes are being used effectively across a wide range of operational conditions. We have tested our processes in multiple environments, and they are sustainable while we're still refining and adapting them. And in level 4, our users have experience with the processes in multiple and varied conditions. They know what to do and when to do it. And then finally, level 5, optimizing. At this point, we're pretty much good at everything. We have the right processes in place, we have the right training, people have used them in so many different scenarios that they're comfortable with them. Then we move into optimization, because there are always little tweaks and fixes we can do to make the process even more efficient and more effective. I think in my real life experience, I've only worked in places that were level 2, 3, and 4. I don't think I've ever been on level 1, and I don't think I've ever been on level 5. And for the exam, I don't think you need to know in deep detail what each level is, but maybe understand it from the slide over here on the right. Level 1, processes are unpredictable, poorly controlled, and reactive. Level 2, processes are rarely defined and are often reactive. Little better, but not much. Level 3, processes are defined and the organization is proactive. 4, processes are measured and controlled. And finally 5, everything is pretty much good. We're focusing on process improvement. Throughout our software development lifecycle, we do a bunch of testing, and we have covered most of them. But for the Capability Maturity Model, there are a couple that I want to revisit or look at for the first time. So when we think we are done with the software, we do the acceptance testing. And we do this to ensure that the software does what it's supposed to, it is robust, and it is secure. User acceptance testing is really what the name sounds like. This is the user testing the software and accepting it for the functionality they requested and the software should provide. This is the application users and the application managers testing the application and using it as they would in a day-to-day operation scenario. And here we might discover some things that doesn't work the way they should, or something that's not intuitive. The fixes might be pretty easy, and we are there to deliver a piece of software that does exactly what the users need it to. We will then do operational acceptance testing. Here we test, does this work with everything else? Do we have all the operational stuff in place that we need to ensure that this system functions both with the other systems it needs to? And do we have all the practical stuff in place? Do we have backups? Do we have disaster recovery? Who's going to do the patching? When are we going to do the patching? Have we checked the software for vulnerabilities? And on and on. all the same things that we go through with all our other applications. We know exactly when we do things and how we do them. And if the software is not built by us for an in-house use, but it is someone from the outside that has built it for us, or we have built it for another company, then we have a contract acceptance testing, which is basically, does what we promised the software could do in the contract live up to the promises? And all the promises, all the what's and the where's and the how's for the software will be defined in the contract. Then we would also do compliance acceptance testing. The name makes sense, right? Is the software in compliance with the rules, the regulations, the laws that governs our industry or our country, the ones that we are obligated to adhere to? And this would in most cases also be part of the contract, but we have to ensure it is in compliance and that we're not breaking any rules or regulations by using the software. And then finally we do compatibility or production testing. Are the interfaces that this application has exposed to other applications functional? Does the data come across like it should, and can they talk to each other in the way that they're supposed to? And then finally, platform. This is where we determine if the software functions exactly like it should. It might have done that in the test environment, but does it do the same in the production environment? They're not always the same. One of my colleagues worked on a project where we had a third-party vendor develop software for us. We gave them the hardware specifications we had that we were going to use the software on, but they didn't have that in their lab, so they used what they had that was closest. At the point where the software should have been done, and they came on site to install it and configure their systems, nothing worked, because it was designed for the wrong platform. They got lucky. I think they spent another 2 weeks coding, and then it actually worked. But when you do that kind of duct tape solution and not what it was really designed for, a lot of times you open up for vulnerabilities.